power of 10 is the result of multiplying 10 by itself a certain number of times. 10, 100, 1,000, and 10,000 are all powers of 10. When we work with the power of 10, we are multiplying 10 by itself a certain number of times. Let's start with 1. When we multiply 1 by 10, the value of the 1 is increased 10 times for a total of 10. There are 10 groups of 1. We call this 10 to the first power. The digits have shifted one place to the left in our place value chart. When we take 10 and multiply it by 10, the value is increased 10 times for a result of 100. Again, the digits have shifted one place to the left in our place value chart. There are 10 groups of 10. We call this 10 to the second power, or 10 squared. Why do you think we call it 10 squared? The array that is formed when we multiply 10 times 10 is in the shape of a square, so it's referred to as 10 squared. What if we continue and multiply 10 times 10 times 10? We can think of 10 times 10 as being the same as 100. If we take a 10 times 10 square array, it is equal to 100. We need to have 10 groups of 100 to calculate 10 times 10 times 10. We can continue adding groups of 100 until we have 10 groups of 100, which is equal to 1,000. We call this 10 to the third power, or 10 cubed. Why do you think 10 times 10 times 10 is referred to as 10 cubed? The resulting model of 10 groups of 100 is in the shape of a cube. The dimensions of the cube are 10 by 10 by 10. Let's see how we can represent a power of 10 using exponents. In the equation 10 times 10 times 10 equals 1,000, we can represent the 10 times 10 times 10 as 10 to the third power, or 10 cubed. The base is the factor that's repeatedly multiplied, in our case 10. The exponent 3 is the number of times the base is multiplied by itself. In our example, it is 3 because we're multiplying 10 times 10 times 10. When we combine the base and the exponent, we have our power. In this case, it's a power of 10 because our base number is 10. A common misunderstanding students have is thinking the exponents are factors. In our example of 10 to the third power, many students think this represents 10 times 3, which is equal to 30. 10 to the third power does not mean 10 times 3, but rather 10 times 10 times 10. We know this is equal to 1,000 and not 30. When we write powers of 10 using exponents, we can look for patterns to help us figure out the products. What patterns do you notice in our equations? The value of the exponent tells us how many times 10 is multiplied by itself. For example, in 10 to the fourth power, we can see that 10 is multiplied by itself 4 times. Another way we can write powers of 10 using exponents is to write the value of the power as a whole number. What patterns do you see when we write our equations in this format? The number of zeros in the power of 10 is equal to the value of the exponent. For example, in 10 to the fourth power, there are 4 zeros in the product of 10,000, which is equal to the power of 4. This makes sense because each time we multiply by 10, we are shifting to the left in our place value chart. If we shift to the left 4 times, we end up with 10,000. Let's return to our original problem. How can we use what we know about writing powers of 10 using exponents to help us solve this problem? 10 to the fifth power means the same as 10 times 10 times 10 times 10 times 10. Since there are 5 zeros in the factors, the product will also have 5 zeros. 10 to the fifth power is equal to 100,000. 100,000 is greater than 1,000, so my answer is yes. 10 to the fifth power is greater than 1,000. In this lesson, you have learned how to represent powers of 10 by using exponents.